Dear students, now let's see the remaining topics of Unit 1. So the topics covered by flowchart, pre-model interpretability, and then XAI techniques and the limitations. So this slide seems to be an introductory slide on lecture explainable AI, and it provides the overview topics that will be covered in the Unit 1. Okay. So the first topic will be include flowchart. Flowchart is nothing but a visual representation, the steps involved in a process or algorithm. In the context of XAI, the flowchart can be used to illustrate the decision-making process of AI model. Then pre-model interpretability. This refers the techniques used for understand the data and the problem being tackled before building an AI model. Then third one is XAI techniques and limitations. So XAI techniques are methods used to explain and interpret AI models. Some common XAI techniques include feature importance, partial dependence plots, and shape values. However, XAI also has its limitation, such as complexity of the models, the quality of the data, and the interpretability of the result. So by understanding the concepts, you can gain a deeper understanding of how AI models works and how them transparent and trustworthy. So introduction part, the goal. Okay, to understand how AI system become more interpretable and explainable using various methods. Now let me ask you something. Have you ever seen Google Photos recognize your face or front face automatically? Or maybe when you apply for a loan online, it say application rejected, but it doesn't tell you why. So that's where XAI comes in. So explainable AI is about making AI understandable to humans, so we know why and how a machine made a decision. Look here, point to slide. Explainability means, okay, knowing why AI made a decision. Interpretability means understanding how the models works. Okay, let me give an example. If an AI says the student will fail the exam, interpretability means it is used attendance, marks, and assignments. Explainability means it says because the attendance was only 40%. So XAI is basically a teaching machines to explain their reasoning to us, like a student explaining their homework. See the diagram, start the input and process the input. AI model process the input and generate the output, and finally the result will be came. So the next slide, the flow from the data to explanation. Now let's see how the process actually happens. Everything start with the data, right? Okay, because without data, AI is like a car without fuel. So first we collect the data, which means you can see the picture, the data collections. So first we collect the data. It could be images, text, marks, or anything. Then we train a model, for example a decision tree or neural network. After that we generate an explanation using a technique like lime or shape. So finally the user understand why AI gave the result. So the flow is simple. Okay, so data, model, explanation, and the user. So when you are showing the diagram, okay, imagine I am building an AI that predict whether the student will get placed in a company. First, I collected data like CGPA, communication skill, coding marks. Okay, then I train a model. After prediction, the AI should explain you are selected because your coding marks are high and you have 8.5 CGPA. That's what we call explainability. Okay, interpretability mean can be added the data or model level. Students, this table shows us where in the AI development process and we can make a system more understandable, meaning more trustworthy and fair. Okay, there are the three stages are there. First one is data collection. Okay, so data collection, and then second one is model training, and then third one is post training. Data collection, it focus only ensure the fairness and remove the bias. Okay, so main purpose of this increase the transparency, and then second one is choose the interpretable models. Okay, model training, so it can be improve the human understanding, and then third one is the post training generate the explanation. Okay, it mainly purpose for support the justification. So AI explainability is not limited to just one step. We can make AI interpretable before, during and after the model is built. Okay, let's understand with a practical example. If AI system for scholarship selections, so data collection stage before training, you carefully select what data goes into the system. You remove sensitive attributes like gender, like that. Okay, this ensure fairness and avoids bias for every from the beginning. Okay, then model training stage, which means during the training. Okay, you choose an algorithm like decision tree, which is easy to interpret. Okay, this means you can explain the decision like, for example, the student was selected because their marks above the 90 percentage and the attendance was above 95 percentage. Okay, then the third one is the post training, which mean after training stage. If you used a complex model like a neural network, you apply the tool shape or lime. Okay, this tools will you tell you which feature, marks, income level, attendance had the biggest impact on the selection. So AI is not a magical black box unless we allow it to be one. So by applying the right techniques at each stage, the data model and post training, we can make a decision clear and fair and trustworthy. So remember, responsible AI is not just about the what the decision is made, but why the decision is made. Okay. The next one is pre-model interpretability. So now what is pre-model interpretability? It means we make the things transparent even before the training the AI model. Like how a teacher explained the question paper pattern before the exam. So students are prepared. Okay. The techniques included, the first one is feature selection. So it chooses only the important attributes. Okay. For salary prediction, we pick the experience, educations, okay, not a height or not a eye color, not a hair color like that. Okay. Then second one is data visualization. So it draw the graphs to understand how the data behaves. For example, plot the salary versus experience like that. Then third one is data cleaning. Data cleaning meaning remove errors and biased data. Then fourth one is dimensionality reductions. So which means simplify the large data into meaningful smaller features. For example, if we are training an AI to predict the salary and our data shows uh, men earn more just because of the gender. That's the bias. But we should clean the bias before the training. So the diagram shows that show a bar chart of salary with experience, which means cleaned data and then biased data. So gender biased removed. Okay. The next one is pre-model explainability. So pre-model explainability means we make sure our data and structure are understandable before model execution. So we can use statistical analysis or correlation matrices to find the relationships. So for example, let's say we predicting the exam performance. We can check with the factors correlate more with the marks, attendance, lab scores, project works. Okay, if the attendance has the strongest link, we already know before the training that is an important factor. So when AI predict someone will pass, we can say because the students attendance and the project marks were high. That's how we build the transparency from the beginning. Then XAA techniques. Now the students is the heart of our lesson, XAA techniques. Okay, this is the heart of our topics. Okay, so these are the tools that help explain complex AI models, especially those black box models like a deep learning. So let's learn a few key ones. Okay, so first one, LIME. Okay, the abbreviation of local interpretable model agnostic explanations. So it explains why the model made a specific prediction. Example, why did the AI reject the loan applications? Okay. Then sharp. Sharp means shape like addictive explanations. It shows how much the feature contributed to the final output. For example, in a diabetic prediction, sharp can blood sugar affected 60 percentage, age 20 percentage, and the BMI 20 percentage. Okay. Then GradCam. Okay, so used for image based models. It highlight the areas in the image that are influenced the decision. So example, in a chest x-ray, it highlights part showing the tumor. Then fourth one is counterfactual explanations. It shows how changing input can change the output. For example, if your income was 5,000 higher, your loan would be approved. Okay. So we'll see the next one. Comparison of XAA techniques. Okay, we can compare the XAA techniques. So first one, decision tree. So decision tree is the transparent type. Okay, it has high interpretability and transparency, high transparency. And then lime or sharp, it's a black box advance. Okay, the interpretability is the medium one and the transparency also the medium one. Then third one is neural network. It is a very complex type. So the interpretability was slow and also transparency was slow. And then rule based system. The rule based system, it is more transparent. So that is the interpretability also high and the transparency also high. So the decision trees rules based system are easy to explain. You can follow their rules step by step. But the neural networks like a brain, millions of neurons inside, very powerful but difficult to interpret. That's why XAA tools to peek inside the black box. Limitations of XAA. So even though the XAA sounds wonderful, it's not a perfect. Let's see why. So first one is complexity. Some methods are very technical, so normal users can't understand them easily. Okay, so it is very complexity. Then computational cost. So creating explanations take time and resources. The third one is ambiguity. Sometimes two explanations exist for one result. Which one do believe? So then third one is user understanding gap, which means the non-technical users might misunderstand the visual outputs. And then trade-off. If we simplify the explanations too much, we may lose accuracy. Okay. For example, a deep learning model shows the heat map of an X-ray. So doctors can understand it, but a common person might think the bright spot is a cancer, even when it is not. Okay. So that is the major limitations of XAA. So, alright everyone, let's quickly summarize what we learned today. So, first one is explainability, which means why AA made a decision. Second one is interpretability, how AA works internally. Then third one is pre-model interpretability, which means clean, fair or meaningful data. Then fourth one is pre-model explainability, which means transparent or input or relationship. Then XAA techniques, there are the main techniques, the lime, sharp and then gradcam counterfactuals. Then the limitations, complexity, cost, ambiguity and trade-offs. So final thought, explainable AA is not just creating a smart machine, it's about to creating a machine we can trust and understand. So always remember, a good AA is not only accurate but also explainable and fair. Thank you everyone.